Okay, so multiplying rational expressions containing polynomials. Okay, so I have a list of things we're going to do this, that we will factor. And then we can use the commutative property to line up like factors if you want to. You don't have to line up the like factors, but sometimes it helps. And then our third step we'll be doing is we'll be dividing or canceling the like factors because they go into each other one time. Just kind of like 3 goes into 3 once. So we will factor where we can, use commutative property to change the order if you want to. You don't have to. And then we are going to then do our dividing or canceling. So if we look at this first example here, we have 3a squared plus 6a. Do they have anything in common? 3a, okay? So we have 3a times a plus 2. And then I also have this 3b cubed, right? In the denominator, we have 12b squared. And how about 3ab plus 6b? Do they have anything in common? Okay, 3b. So I take out the 3b, and I'm left with a plus 2. Now, the most important thing is here is that, remember when you're factoring, we're always looking, first of all, to see if I can find the greatest common factor, and then we go from there. So we look for our common factors. And we have an a plus 2 here. We have an a plus 2 there. So since I have that common factor, then they go into each other one time. Okay, now this other stuff that I've got here, I think I'm going to rewrite that before I do anything else, just so it's a little bit clearer for me. Can I actually do multiplication here with these? Okay, that's what's going on, right? Okay. All right, what's 3 times 3? Okay, so we have 9ab cubed over 36b cubed. All right. Now, there's multiplication. Yes, sir. Yep, we could do that. Yep, you could always do that too. Yep. I just wanted to rewrite the whole thing here because to get rid of these and simplify the way it looked a little bit. Yes, you definitely could do that. All right. So now we have another common factor. We have a b cubed here and a b cubed here. Because there's all multiplication going on, I can simplify those to 1. Okay. There's no a's, so I can't simplify that. But does 9 go into 36? Okay, goes in there 4 times, all right? So that's a 1, and here's a 4. So what do I have left? In the numerator, we have a. In the denominator, we have 4. Okay. So a over 4 would be our answer. Amazing. Take all that, and it simplifies to that. Okay. So remember how much time we spent doing factoring at the beginning of this class? Okay. Here's a big reason why we did. Because we're going to come back to it. So, like it or not, and we'll be doing it all when we get into Algebra 2, the Algebra 2 book. Doing it a lot in there. All right. So the first thing we want to do is we want to factor. Right. Can I factor anything out of p plus 4? No. Okay. Can I factor p squared minus 3p minus 10? So what are the factors of negative 10 that add up to negative 3? negative 5, and 2. So we have p plus 4, p minus 5, and p plus 2. Okay, there's our numerator. Notice I'm just putting one fraction bar now because that's all I need. Because multiplication is commutative, I can do it in any order. So I can put a fraction bar there. Okay. P squared plus 2p. They have anything in common? Okay, they have a p. All right, so I can take out p plus 2. And what about p squared plus 16? Can I factor that? What is it? How many p plus 4s do we have? P plus 4 squared. So this right here. That? Ruth's shaking her head no. Why not? Oh, it would. There would have to be a middle term then, wouldn't there? Okay, there'd have to be a middle term with a p here, and there's not. That's correct. So can I factor it, Ruth? She's not sure. All right. How do I know if something can be factored? By what? Actually, I know because if I graphed it, then there would be zeros. It would cross the x-axis. If it can be factored, I could write it so that there are zeros. But the graph of p squared plus any number, if I call it c, is going to look like this, kind of. Oops. It doesn't like me. Okay. It would basically, the graph looks like that, but does it cross the x-axis? No, so it cannot be factored. Anytime I take x squared, some variable squared, and just add a constant to it, cannot be factored, so you just have to leave it that way. So what common factors do I have here? Okay. So I only have one, don't I? I have p plus 2 in the numerator and a p plus 2 in the denominator. Okay. Since those are the only common factors, that's the only simplification I can do. So my answer will be, and you can leave it like this in factored form. So that would be my answer. So when we're multiplying, we are looking for, we factor, look to see if I have common factors, be able to divide them, cancel them out, so that we have a 1 left in the numerator and the denominator represented by them. Okay? And don't forget, there's still, that's represented by a 1, so we have p times 1 times that. All right, just isn't just canceled out, but there's still a 1 there. Okay? All right. Division. For dividing rational expressions. Well, all rational expressions are is fractions, right? What are you supposed to do if you divide it by a fraction? Multiply by the reciprocal. So when we were back doing our warm-up over here, and you did 2/5 divided by 15/7, then I would do 2/5 times 15/7. Right? I would multiply by the reciprocal. So what's the little thing we do then? What do we call it? Copy, change, and flip. That's right. Okay, copy the first part, change the division to multiplication, and then take the reciprocal. So we're going to write it as a multiplication by taking the reciprocal. Then we'll do any factoring we need to do. And then we'll cancel or divide the common factors. So we have 2 over g times g squared over g plus 4. So I'll write it as multiplication. So I have 2g squared over g times the quantity g plus 4. Do I have any common factors then? What do the numerator and denominator have in common? Okay, they have the factor of g in common. So that means then we have 1 there, and g goes into g squared, g times, so we still have a g up there. Is there anything else I can cancel or simplify? Can I simplify this 2 and this 4? The 2 here and the 4 here, can I simplify them? No, because this 4 is attached to this g. All right, so if I don't have g plus 4, I can't do anything to this quantity here. So this answer is going to be 2g over g plus 4. All right, so when it's division, we write as multiplication by taking the reciprocal of what we're dividing by. Multiply the numerator and denominator, so write it as a multiplication problem. Make it 1 fraction bar, factor it, and then simplify. All right, so let's try this one here then, letter B. So first of all, we're going to change it to multiplication. So we have 1 minus n squared times n squared minus 4n over n times n minus 1. All right, took it from a division problem, okay, dividing by this, to multiplying by the reciprocal. So n squared minus 4n went from the denominator to the numerator, n minus 1 went from the numerator to the denominator. Then we want to factor. Can I factor 1 minus n squared? What's that? Well, multiply this by -1 has nothing to do whether I can factor this or not. Can I factor this? No? 40 says I can. 40 is probably right. So what do I get if I factor that, 40? Okay, good. 1 plus n, 1 minus n. Okay. All right, it's the difference of 2 squares. How about n squared minus 4n? Sierra, can I factor that? Okay. This is n times n minus 4. Okay. Can I factor anything out of the denominator? Or is it already factored? As much as you can. All right. So we have n times n minus 1. All right, so let's look for our common factors. Do we have common factors there that we can simplify? Shelby? Okay, they both have an n. So n goes into n 1 time. Those are 1s. Anything else I can factor right now? Dylan? I know. Is there anything else? Okay, it doesn't look like it. All right. Can I make it so that I can factor or simplify? Yeah. Okay. All right, because we have 1 minus n and n minus 1, right? Those two are the opposite of each other, aren't they? So if in the numerator I make the whole thing negative, I can change 1 minus n to n minus 1, can't I? All right. By factoring out the negative out of 1 minus n, I have a negative out front. I can change that 1 minus n to n minus 1. And then we can simplify those two parts. So my answer is going to be negative quantity 1 plus n times the quantity n minus 4. All right, so the big thing here is being able to factor. If you can factor, you can be successful. If you need to work on your factoring, then all right, let's work on that. All right, how about letter C here now? It's right here. You got it, Wolverine? All right, good. Is that better? Okay. So here we have 4xy squared over y divided by the quantity 2x squared plus 6x. So is this 2x squared plus 6x? Is that in the numerator, the denominator, both, neither? It's in the numerator, right? It's over 1. So that means then when I copy, change, and flip, I have a 1 in the numerator, and 2x squared plus 6x is in the denominator. Okay, what do I do now? Okay, is there anything that's a like term right now? No? I don't think so. Justin, what do you think? Two x and 4x? Okay, so this 4x and this 2x squared, I can simplify them. Okay. There's this plus sign here, right? Because that plus sign there, this is all got to stay together. Okay, the denominators all got to be together there. Okay. Do they have something in common that we could factor out? Okay, they have a 2 and an x, right? Right. So we could rewrite the numerator as 4xy squared. And the denominator, we have a y. We have 2x and x plus 3. All right. So here we have a y and y squared, right? So I could take a y out of both of them. Okay. We have these x's. that are here. Those are factors, right? They're being multiplied. They're not being added to anything. Okay? And then we've got this 2 goes into 2 once, goes into 4 2 times. So we have in the numerator 2y, in the denominator x plus 3. Right, so it's all a matter of factoring and looking at common factors. All right, so make sure you're not just crossing things out because there's something that looks like in the numerator and something looks like in the denominator. It only works if there's multiplication going on. All right, I was able to factor here or cancel here because I had the common factors. Where over here I couldn't do it because I have that plus sign in between there. So these have to stay together, 2x squared plus 6x here. But once I found that common factor, now that I've written them as factors, I can go ahead and do that simplification. But make sure you've got common factors to be able to simplify. Multiplying going on. If there's ever a plus sign or a minus sign, then you've got to have that plus or minus in both parts. Okay, like we did here. Like here, oops, like there and there. All right, because they both have n minus 1, I can cancel them, simplify that part, because they're exactly the same.